So 8051 timers. So timers are used to provide a specific delay or probably a specific counting event can be performed using 8051 timer. So they are the individual or independent blocks which runs along with the crystal frequency as well as with the external frequency. So there is a structure for this timer. So this is the internal structure of an 8051 timer. As you can see, timer is realized having a counter register here. So it is timer or counter because two purposes are served here. 8051 as a timer or counter. So generally we call it as timer, and internally it consists of a counter register which is called as TL and TH. Now these are 8 bits here in 8051. What happens here, the oscillation frequency, whatever oscillation frequency that we use, it is passed through a divide by 12 clock. So divide by 12 logic, that output is given as a counting event for the timer registers or a counter registers. Now before it goes to this counter register, it has to have few enable lines. There are two enable lines. One is C/T bar, which actually selects whether you want it as a timer or a counter. Now let's get into the meaning of a timer and counter with the C. In 8051, timer is generally used to produce the delay, and the timing events are driven by the clock frequency, the internal clock frequency. So any clock signals for this timer are taken from the internal clock. When you select it as a counter, that is C bar T equal to 1, it selects the counter. So that is the register value, there is a bit for this. So in this TMOD register, as you can see, C bar T. So this bit, if you make it 1, then default it is selected as a counter. So there is a separate T pin which is with the port 3. You have to provide the clock. Now this is an external clock. It could be an event. It could be a digital event that goes from high to low transition. So randomly or maybe sequentially. So it depends on what nature of the signal that we use the TP pin. So that is external event, you can give it as a counter. So main difference is generally timer we use it to produce the delay, whereas counter we generally use to count the events. Okay, we need to count the event. Maybe the person crossing some place, the vehicle crossed in a road. So we want to count it. So we use an infrared beam to set the count value, get the get the trigger values, trigger signals, and that trigger we give it here, and we can configure it as a counter. So every trigger, this count will increment by 1. So this is how the counter selection is made, and timer selection can be made. Apart from that, there is a control bit to start the timer. The control bit to start the timer goes from series of these control signals. So there is a definite control signal logic need to be fed to start the timer. So what are these? So let's before that I will give you some details about the registers. See, look at this. There is something called as TMOD register. TMOD register and TCON register. See, they are the timer registers. So one is a mode control register, another is the control registers. So in 8051 there are two timers. So I think that, see, in 8051 there are two timers, timer 0 and timer 1, and these two timers can be used in different modes. That is, timer 0 can be used in mode 0, mode 1, mode 2 and mode 3. Timer 1 can be used in mode 0, mode 1 and mode 2. Now if you look at this mode, to control all this mode there is a register that is called as TMOD register, and there is a register to control the timer operation. So there is something called as this TMOD is a 8-bit register which is mapped in the SFR special function register, which has the mode control register for both the timer. The first 4 bits, that is the lower nibble for the timer 0 and higher nibble is for the timer 1. Now coming to the definition of this TMOD bit. TMOD bit, if we see here, TMOD bit is the M0 and M1 bit. Okay, M1 and M0 bit. M1 and M0 bit that defines the mode. It can have 0, 0, 0, 1, 1, 0, 1, 1. See, when you have these values, it will select the different mode. As I said, first is actually the mode 0, which is a 5-bit, 8-bit timer as 5-bit prescaler. Mode 1 is a 16-bit counter. Mode 2 is an 8-bit counter, and we have also mode 3, and which is supported by only one timer. Okay, now we have to see a simple example with only mode 1 and mode 2 how exactly it can be configured. Coming to the next bit, that is next 4 bits, that is for the timer 1. Again similar bit will repeat. M0 and M1 will select the mode for the timer 1. Now apart from that, again see this C bar, T bar, C/T bar is a timer or a counter selection bit for the timer 0, and similarly here is timer and counter selection bit for timer 1. There is some bit called as a gate. What is this gate bit is? The gate bit is a bit which used to control the timer or a counter with an hardware pin. So if you want to control your timer using a hardware bit, maybe an IO line, if you want to control, then this gate bit has to be used. According to the definition, if you see, when set, the timer or counter is enabled only if the int x pin is high and trx is set. So the two bit will come control the timer. One is the timer run bit, that is tr bit, another is the int pin, which will also to be high to start the timer. So this condition will be possible only if the gate bit is set. So you don't want that, then you make gate bit 0. Then it is only the TR bit which controls the timer. So in general, what I can say is that the timer is controlled either using a software bit and hardware pin, or only software bit. So this is what happens. So with this TMOD, so TMOD, I hope it is very clear now. All these definitions of this 4-bit for the timer 0, another 4-bit for timer 1, the TMOD. There is one more pin, so that gate bit is what you see here is here. In this block diagram, there is a gate bit, and C/T bar is here, which you can realize how the selection is made. Now coming to this TMOD, let's see. As I mentioned earlier, if this bit is 1, then you have to have the logic of int pin to be considered. See what happens here. See, ultimately when this switch has to be closed, ultimately this switch is to be closed to start the timer. When this bit is to be closed, it means this pin should be at logic 1. Okay, this should be at logic 1. So what happens when you want it to be at logic 1? So if you want this bit to be at logic 1, then this TR bit should be made 1, and this is an AND gate. This bit also to be made 1 if the AND gate output should be 1. So when this bit becomes 1, look at this. If gate bit is 1, there is a NOT operation which gives it 0. There is an OR gate. I expect this to be 1. This is 0 here, and this is 1 here, I expect. So what should be the spin status if I want this to be 1? So 0 OR with something gives you 1. Actually it should be 1. So when you make this gate bit 0, 1, when you make this gate bit 1, the INT pin has to be at logic 1 to start this timer. Let's look at the other case when gate bit is made 0. When gate bit is made 0, then this NOT gate will make it 1 here. Whatever the status of this INT pin, irrespective of that, this output is going to be 1. Correct? Whatever the status of this INT pin, the output is going to be 1 because OR gate 1 input is 1. So you know the OR logic, anything ORed with 0 or 1 gives you 1. So the control mainly depends on now TR pin, timer run pin. So this is a simple control logic which is kept to incorporate this TR, gate and INT pin into the control of a timer. So once this is activated, now the timer register starts counting. So once it starts counting, there is something called as an overflow. So timer generally starts in an incrementing fashion. You load a value, it will start incrementing. Once it goes to a final value, that means when it completely ends up with the last number, then that is treated as an overflow. Overflow in the sense, here it is 16-bit timer. So value is 16-bit. So once it starts, they say timer value is loaded with say 0010. Now 0010 is a value which needs to be incremented. 0011, 0012, so on, it will go till FFFF. Again one more pulse will be given and FFFF becomes 0000. That is called as an overflow. The overflow indicates when you exceed the limit of that entire 16-bit. When you will exceed the limit of the entire 16-bit, when you get one more extra bit as a carry, then only it is considered as overflow. That is overflow. That condition of overflow is indicated by TF flag, which is an extra bit that comes when the value goes more than FFFF. When it increments by 1, then this bit becomes 1, indicates it as an overflow, as an interrupt. So this is a basic structure of working of both timer and counter. The counting and timer, the process only changes with the clock selection. That's it. The internal working of this counting remains same both for timer and counter. After the overflow, there is a bit is generated. I can use it as an interrupt to start or stop the timer. So the further about this, we can have a look to understand the functionality of timer in different modes.